Data in transport, one of the mysteries of the Web3. Happy to see that even the centralized counterparts of what we're building at HOPR has its issues. So, I'm Sebastian, I'm founder of HOPR, and I'm going to talk about privacy infrastructure in the Web3. And while we just heard a bunch of things on the on-chain privacy side, which I'm really excited about, which I hope to see much more of, we are working on the transport layer at HOPR. And the transport layer is something that's a bit mysterious to many, so I hope to give some context to that one and what it has to do with Ethereum. So Ethereum is a dark forest. And as you walk your way through the dark forest, you realize you're not alone. There's other equally small and defenseless creatures who are also grazing the dark forest. And as you make your way through these thick undergrowth of this dark forest, you hear a noise, and you turn to the light, and what you see is not good. There is creepy invaders of the dark forest that leech the life out of you and the fellow creatures of the dark forest. And as they make their way through the dark forest, not just you and your fellow creatures suffer, but the dark forest itself catches fire. The dark forest is dying. Can we do something to heal the dark forest? There's hope. And hope in restoring this dark forest and protecting all of us, or as I like to say, to regrow the dark forest. What I'm talking about here very much is what is actually really happening on Ethereum today and how much worse it could get going forward. So we're looking at that fundamental issue at HOPR, again talking about privacy infrastructure. And I want to highlight one specific issue that we see in the Web3 in a bunch of domains. So what does it actually mean? Like, what actually is the problem around interfacing Web3 infrastructure? So let's look at a couple of typical examples, right? So you might have some applications, Ethereum, some other chains like Gnosis Chain, IPFS, the Graph, Pocket Network, all great decentralized infrastructure. But in fact, you're interfacing that today through Web 1.0 technology, right? So Web 1.0 technology is the magic that connects peers in these peer-to-peer networks. Yeah? So you're a peer, and there's many other peers out there that connect using Web 1.0 technology. Now, users increasingly are, and I'm very much respect that, are kind of anon users that respect their privacy. And privacy is something that many of the major users of the Web3 cherish quite a lot. Yet the technology at the most fundamental layer that we utilize here do not have that as an explicit goal. How do we fix that very issue? To make it even more precise, let's walk through one example. You're interfacing Ethereum today. If we look forward, we don't just have these centralized applications. We all talk about decentralization, and that is great. But again, all these dApps, right? The D in the dApps is like typically not capitalized. Like it's not very decentralized today, for good reasons. Many of these kind of intentionally decentralized technologies are not decentralized and are also not having any way of defending privacy on the most fundamental layer. So any exchange of data from users to any sort of other peers in the network needs to be protected from the ground up to have meaningful privacy, and that is what we engage in our work at HOPR. Otherwise, if we don't get there, we have the examples that I've kind of referring to more loosely in my introduction of MEV. We see MEV is a multi-billion-dollar issue, but actually the harvesting that we see today is just the tip of the iceberg. Searchers, which make these billions of dollars, are only extracting information out of the mempool, right? This pool of pending transactions. Now, there's so much more that you could harvest once we get to these amazing, truly decentralized technologies. Yeah? And our ultimate defense against that data harvesting at the expense of individual users is privacy. Privacy is everyone's insurance policy against getting exploited by parties that we know exist. And we know and see to the tune of $1 billion that they will do whatever they can in order to make money. Now, how do we tackle that at the most fundamental level? So, one example that I let you check out yourself is DERP, which is a dumb Ethereum RPC provider. I'm not going to demo it here right now, but I invite you all to check and connect to this DERP RPC endpoint, which works with any wallet and shows you what is going under the hood and what exactly your wallet is disclosing about you before you actually even start using it for real. So yeah, that's just to highlight what is going on. Now, how do we solve that? We solve it by actually building this data exchange layer, this HOPR network, which is unlinking the users from other peers in peer-to-peer networks. So it's a bit like a VPN or a bit like Tor, but more private. Now, how is it more private? Just a short look behind the scenes here. So in HOPR, we are sending data packets through multiple intermediate hops, right? So data packets are kind of hopping from one user through multiple of these nodes, which are relaying data packets. So once they get to Zoe, in our case here, the recipient of data, she doesn't know where exactly the data came from because she only sees the peers that she's connected to, but not the ones that actually send the data packets on the get-go. Now, some of you who are familiar with Tor, who here has used Tor? Anyone use Tor? Nice, this truly is a privacy conference. So, you know, some of you might be using Tor and you might say, hey, this is actually looking somewhat similar to Tor. And that is correct. Tor is employing, for the ones who are not so familiar with Tor, Tor is employing this multi-hop routing to obfuscate where things come from and where they go to. Now, there's two important differences that we improve beyond Tor. The first one is we make Tor actually way more private. So we're now zooming in to one of these mix nodes, and what is actually happening is that data packets are being cached for a short amount of time. They're transformed, so they look different when they come out, and then they're sent out in a different order. Now, why do we do this exercise that does sound a bit painful? It actually is a bit painful, and that's why latencies in mixed nets are typically longer than in other packet relay infrastructure. We do that so that nobody, even your internet service provider, who sees every packet that comes into your router and goes out, sees what packets are being relayed where. So in other words, mixing and transforming of packets is unlinking technology, right? So you prevent anyone from linking incoming and outgoing packets unless they have kind of full access, like root access to your computer. Cool. So that's why HOPR is called a mixnet. Mixnets have stronger privacy guarantees than Tor. If you talk about trust assumptions, typically in Tor you rely on the fact that the first and the last nodes are not colluding. In mixnets you only need one honest mix node along a path. So it's stronger, it presents stronger assumptions. Now, the second one, I've asked who has been using Tor, and I've seen like roughly 50% of hands up. Who here has ever been running a Tor node? I don't see any hands. Why do you think that is? We have a minute of reflection now. Why are you not running a Tor node? You don't know? No, probably you know. Like, probably your question is like, why should I run a Tor node, right? Why should I run a Tor node? And that is not a selfish answer to my question. That means it is like just not rational to run a Tor node. It's pretty cool, I agree, but it just, there's nothing in for you, and there's quite some cost, legal risk, running servers, and so on involved. So in other words, you see where this is going. We're in the Web3 space. Tor is not incentivized. So we bring incentives that respect privacy to packet relay infrastructure at HOPR. Now, let's look into how that works. It's another representation of the network that I showed 2 slides earlier. On top here, the mouse is too hard for me. So on top, you see these data packets that are hopping from one node to the next. And you see, in fact, this onion encryption. You see these shells, these dark blue shells in this yellow ball that is hopping there, are being taken off, right? This is very similar to how Tor works, and that's what's called onion encryption. In parallel, on the bottom, you see the payment flow. You see how every of these relay mix nodes is extracting some amount of HOPR tokens that are being extracted upon forwarding the packet. Yeah? So we have the payment flow on the bottom. Now, the interesting thing is that you see that there's this key half coming in, and only with access to the key that you get from the next downstream node are you able to extract a payment. And that's something that we call proof of relay. You provide a proof that inherently guarantees that you only get paid when you correctly forwarded the packet. So if you're trying to be funny about it, and flip even like a single bit in this packet, that's not going to work. Because the next downstream node is going to check the integrity of the packet, realize something has been tampered with, and you will either not get a key or you will get the wrong key. And therefore, you will not receive your payment. So, this is how crypto networks, in my view, should work. You have a bottom-up system that ensures the correctness and the correct operation of every participant in the system. We don't need to have, and this is maybe for the ones who are a little bit deeper into Tor, we don't need to have like these watchdogs that are measuring you and trying to find out, are you doing a good job? Because if you're not doing a good job, you just don't get rewarded for what you're doing. In the worst case, you just drop packets, you don't get anything for that. So that is the second, advance that we do on this infrastructure. So, as we say, changing data privacy for good. Now, how do you actually get to use that? That sounded pretty abstract, and that's true, right? This is general purpose infrastructure. How can you as a user actually use that? And like many infrastructure, you don't actually use it. Like when you use your phone today, you're not manually using the TCP/IP stack that is Web 1.0 technology that I was referring to earlier. So at HOPR, we're actually working on a product that runs on top of this general purpose infrastructure. And this first product that we're working on and that a bunch of people here were hacking on, which I'm very happy about. I know it's sometimes still a bit quirky because we just had our earliest alpha release about a month ago. So this is very early times for this first product. Is providing an alternative to the RPC providers that you might know from your Ethereum or other crypto wallets today. So when you connect an Ethereum wallet, what actually happens is you're not connecting it to a network. Like that's in my eyes, by the way, a really funny thing. Like, this drop down in MetaMask, people here use MetaMask, I assume, right? You have this drop down that says network, choose your network that you want to connect to. And it's pretty crazy because do you connect to a network? No. Actually, sad news, you don't connect actually to a network. You connect to somebody else's server. You connect to a server that sends data to you. Now, that's not great, right? So I see why people change that to network. But you're connected to somebody else's server, which gives you data that you, by and large, blindly trust. And you also trust them to not data harvest you as you use your crypto wallet. So that's why RPCh is the first truly private RPC provider that tells your wallet, what is going on, about the transactions that you are going to make, what is your ETH balance, and so on. Because these data is being queried even when you don't use your wallet, right? You just start it, you start your laptop, you unlock your MetaMask just because you're about to do something later. But already at that point, you're subject to data harvesting. And that's something that we want to improve. And if you want to check it out, can I ask private RPC? Yes, you can has access.rpch.net. You're invited to check it out. It's for free in this alpha phase. If you don't want to be data harvested when you use your MetaMask, this works with any wallet on any chain if you download our Docker container. And if you think that's too quirky, I invite you to check out Block Wallet, which is also here. There's an experimental version of Block Wallet that's linked on the access page, where you can use RPCh in production right now on Gnosis chain. So that's the first integration we have there. And with that, I close up here, and I'm open for questions if there's any.
Hey, thank you. If Ethereum choose enshrined PBS, relays will completely disappear. What happened to proof of relay?
Sorry, what happens to proof of relay? What?
Yeah. If Ethereum Foundation want to choose enshrined PBS.
If Ethereum Foundation
implements the enshrined PBS to
PBS. Yeah. So, I mean, if you have proposability separation, that's what you're referring to, right? Yeah. From a user's perspective, not necessarily too much changes, right? So even with like PBS, I am, as a user, my wallet is going to use an RPC provider, right? So PBS is more involved like what happens afterwards, like further down. Like specifically what I'm concerned about is RPC provider are in a privileged position to mess around with your data. RPC providers are in a privileged position to shortcut that entire circuit that you're referring to. RPC providers are the first to see something that you see before you even see it, right? So if you go on any dApp's website, like there's so many things that is being loaded through the UI. So that comes typically through the RPC provider. So no matter what happens further downstream, that is an issue where data gets to be made available and harvestable. Any other questions? I'm around also afterwards if there's more discussion points. Thank you so much.